Okay, are we live? Seems we are. Okay. So today, I just want to progress with the testing that we're doing of the embedded Rust. So previously we managed to, we actually added an Arctic scheduler into our program, so that basically we're using it now to control and schedule our tasks. And apart from that, we have interrupt working that flashes or blinks our LED, and we have an idle task that plays a little tone over the PWM output. I don't have it hooked up here, but yeah, it works. We can probably test it later. So what I want to do today is I got a little LCD display like that. It's 128 by 160 pixels, 1.8 inch, I guess, display for Arduino and stuff like that, with a optional SD card reader, which we're definitely not gonna do today, but we will try to hook it up into our Blue Pill. So it uses the SPI protocol, for sending data into it. So basically the goal today is to get the SPI working, and hook it up and hopefully display something on it, without basically messing up the stuff that we have there currently. So we just want to integrate it into what we have. Yeah, I have the data sheets here ready for the for our STM chip, and this is the data sheet for the driver, or yeah, for the LCD display. This is our Cortex Arctic stuff. We're probably gonna need the STM32F1X Hall crate, which is this. Yeah, and in here we probably gonna have to check how to configure the SPI interface. There's definitely an SPI example here using DMA, but we're not gonna use DMA here. Because it's been a long time since I used DMA, so I probably gonna have to brush up on this, but the SPI should be pretty straightforward. Yeah. And the other thing that we can check straight away is to see if there's any ST7735 libraries, and they are. and that looks, yeah, like what we want. Oh man, another cutting edge stuff. What we'll see. It's a fork. Documentation is here and examples are here. And look at that. What more could we want? Examples. Draw ferries. Okay, looks like we cut down on our work by 98%. Okay, so I guess let's get to it. So we are going to I guess we'll start by configuring the SPI stuff. Okay, need a couple of imports, 16 megahertz, SPI. Those are our chips. Okay, so let's have a look at the imports. Resources, DMA. Okay, so I guess SPI, yeah, SPI. That's going to be probably quicker. So we will need also mode, polarity, and phase. We were using GPOB before. There. Okay, we're definitely going to need this. So this is a reset pin, and this is, what is it, a data select. That's clock, output, and input. So that's basically exactly what we need on the on our display. So let me just hook it up. Okay, and this is weird. So that's blue. Okay, so this is a weird part actually, because the example here configures the MISO pin. But our LCD doesn't use this. So basically, even though we configure this pin, we don't actually hook it up to this, at least this model of LCD that I have in here. So just floating in there. Okay, so that's interesting. So I'll just maybe take a resistor and I put it to ground. Okay. And then we have LED. So we want it always on, so that goes to 5 volts, and VCC, which is 5 volts, and there's a light on display, but there's nothing on it. So hopefully it will change soon. Okay, so that's that. Okay, so we have our SPI here. So now we need to initialize the actual LCD driver, which is this dude. Okay, where's our example? Okay, we already have a delay and the display. Okay, so we need to import it. So 080 alpha 1. Okay. So we have that. Display init, delay, set offset. Okay, we're not going to be displaying the image, but we will try to type something, display some text definitely. We need orientation. Actually, no. We do it like that. And RGB. Oh, that comes from, so embedded graphics is the another crate. It's similar like embedded HAL or embedded HAL. So basically they're just this is a collection of traits that is, it's suggested to be using those whenever there's whenever one wants to write drivers and stuff like that. It's the similar idea like the one behind embedded HAL. And I think there's also embedded time and embedded error, I believe. So there's this kind of this standardized way of writing your drivers or HALs. Okay, so we will need this. And we need to find out what's the what with those alphas. It's actually, yeah, it's graphics. Blah blah blah. Finally. Okay. Use embedded graphics preload. Okay. How about this? Okay. So cannot. We are passing the delay into okay. Okie. So this should at least allow us to see if the LCD is working. Is there green? Yes. Something nicer. Oops. So we should be able to load this. And there is nothing happening. Oh. Oops. Nope. I know what is the problem. See this, the SPI is running on 16 megahertz. So that means we need to run our clock faster. So actually there is a use use high frequency external, something like that. Let's have a look. It should be in the example actually. High speed external. So actually, boom, we're still in it. So that means we use the external oscillator that's coming on the board, and its value is 8 megahertz. Then we configure the system clock at 72 megahertz. This is the PLC peripheral clock, 36 megahertz, and that's the clock that's feeds into the SPI. I think. Let's have a look. And boom. Isn't that green beautiful? The LED is too bright. So let's hook it up through some resistor maybe. Okay, is this less bright? No, it isn't. Okay, maybe 1K. Okay, this one is too high. Okay, I don't have any other resistors here. That's actually, I don't remember, I think it's 47K. But how about this? Just hook it up to 3 volts. Nope, still. Okay, trust me, it works. Okay, maybe I do have a resistor here. Okay, I don't, and I'm not gonna be wasting time now. Okay. Let's go back to the stuff. But at least we know that this is working. But we're not going to be doing this in our init function. So I guess, well, we will move this into our idle function. That's where we want to keep, that's where we're going to be updating our display with stuff. So that means we will have to configure our, well, add it to our resource struct. So I think we could probably let's clean it up a bit in that case. Okay. So instead of passing the PWM in here and then creating the tone, let's just pass in the tone instance. Like this. And then we can just play the tone. But that means we need to initialize it in our init function. So this is our PWM. It's create tone. Yo. here we are going to pass in our PWM and channel C1. But the last time, in order to get it working, we did this. So actually it turns out to be nice, much nicer now, because we can get rid of the mutable reference and just take ownership of the PWM as we had it originally. Okay, and I think this won't compile until we... Oh geez, I'm not typing this again. PWM ton. Like this, and then we have just ton and then PWM ton. Can't click private type. Boom. Actually, let's keep this private, because that cannot be public, because we can, in order to play it on, you have to enable it, and we're enabling it in here, so we probably would need to modify this a little bit. So what else is? And finished. We're making such a progress. So much cleanup. Okay, so now we need to move the display into our idle. And again, in order to do so, we will configure the resources for that. Display. Yep. And so what type is that? Ah, jeez. Okay. So display. So it's this, and then there's SPI in it. Okay, and let's consult the documentation. So actually it's this. So it's a SPI DC and reset. So it's SPI and then it's a PB1 into push-pull. Ah, Jesus. So type DC. So it's a QPO B PB0 and PB1. So PB1, and that needs to be output push pull, and it's the same for reset. Is that correct? Reset is PB0. Yes. Okay, so it's SPI. Where is it? SPI DC and then reset. And then we need to configure the SPI, and then SPI is SPI remap pins U8. So there was U8. And then remap, no, pins there. So they have to be in correct order, I think. But let's double check examples. Yeah, I'm not sure though. Oh, and we need to import those anyway. So 5, 6, and 7. So SCK MISA C. Oh yes. Ugh. There. Okay, so I guess the order doesn't matter. I think. machines. That's implemented for multiple combinations. Okay. That's helpful actually. Okay, so this, what do we have here? 150 mains not found in the scope. Oh, sorry, display not found in the scope. That's because we're using the lazy notation. So PA6 was supposed to be input floating. Interesting. Okay. So yes, I guess we can do this initialization here, but then we go right to here. Okay. So we will want to display something here, I guess. So statically, so display, display, and display. So let's see how we can display something here. Draw target. Draw line, draw triangle, draw circle. I just wanna draw text though. So for this, I think we need to go to this library. So this grade aims to make drawing 2D graphics primitive super easy. Exactly. So it's perfect for us. Note that some drivers may not support the latest version of embedded graphics. Are those the ones that not supported? Because that's the one we're using. So anyway, we want text. We want exactly this. Okay, so let's grab those imports. Pixel color, won't need this then. What's going on? Unresolved input. Loop unexpected. Ah, we have a syntax error. Oh yes. Okay, we'll come back to this. So blab, this, okay. So you have to do all of those shenanigans then. So style and then text. Why is this stuff text builder, text style? Text, it's not here. Text style. Oh, monotext style builder. Okay. That's better. And then we just do this. Oh, yes, we need this display. Ah, so that's how that works. Okay, so let's just okay, what's here? It's not implemented in blab. Ah. The trade bound blab. Yes. Do we need to unwrap? Oh my god, are we displaying stuff? We're about to. Oh man, this is so frustrating. Okay, let's change the background to black. That I cannot share this beauty. Green. Being so flamboyant turned out to be a mistake. Okay. But it's there, it's displaying, trust me. Holy shit, this is bright. But anyway, it says hello Rust. Yes. Okay, but this is too much stuff to be displaying it. So we're going to encapsulate this a little bit in that case. So we will keep this stuff. So what is this? Monotext style. Nice and simple object. So style. What was it? RGB. This stuff. And what? And a font. Yes. Okay. And then we import it. And let's give it a new. And yeah, let's keep it simple. There. Ah yes, because all of this is outside the okay. And we need show or text and yeah, just text, and we will need the coordinates and y, and that doesn't return anything. Yes, so text x, y, self. Oh yeah, and obviously we need the display as well. Yeah, and we know what our display is. It's this. So we will need to take a display here. So actually it's even better. Instead of doing that, we can just do it like that. And we will just share the display. And then all of this can go here. Let's see. Yeah. Okay. We will clean this all up later. Should have done it straight away. Okay, so in this case I should have left this, but remove this, because otherwise we have a conflicting there. And we'll see if we can change it later. Okay, and then this Okay, we made a little bit of mess with the types. Okay, so here is expected 166. Yes, so what we're doing here is that it's this, I don't know. So that okay, now we're getting there. Okie, and then 211. So this needs to be moved. Alrighty then. So still need some cleanup. So 17. So main errors. This. Blah. Okay, so let's finally start displaying stuff. So will that work? Print text. We're printing so 10 pixels, 30 pixels. Nice. Okay, it's initializing. And we're printing. Oh man, such a pity. I wonder if maybe okay, red and then more black. Oops. Yes. The perfect match, red and black. Okay, I'm gonna have to pause here for a second. We're back. Yes, I had to go and put my kids to bed. But we can continue where we left off. Actually, the kid is sleeping just beside, so if there's any noises, it's from over there. Okay, so let's do something a little bit more interesting now with the with the screen, and instead of printing static strings, let's print out some dynamic data. So for this, let's create a variable counter, which is going to be u32, I guess. I think we can do something like that. That's going to, the article is going to initialize it to 0 then, without us doing this explicitly in the init function. Is it though? Yes. And let's take our screen and rotate it as a portrait, so lengthwise. We swap those around. Yeah, and let's see. There. So it's actually better. Okie dokie. So we have the variable now. So notice that once we use the init macro and specify the value we wish to init to, we don't have to initialize it explicitly in here when we're returning the late resources. So what does it mean now? It means that now we can take it here and we can use our timer task to initialize the variable and not even initialize it, to modify it. There. And then we can take it in here and read it. There. What does it mean? Yes, unused. And now we can actually take it and read it, and then just simply display it on our screen. The only problem here is that while printing static strings is straightforward on embedded, with dynamically generated strings we will have problem, because something like that is a no-no, because the string allocates stuff on the heap and we have no heap. So there's something called there's a crate called heapless, I think. That has a string that we can use. So essentially it gives you a string with a length that we can specify, and apart from the fact that we need to specify the length of it, we can use it as the string that's available in the standard directory, or the standard library for that Rust has. So we better use heapless. And this is, are we going? Okay, no alpha. Lucky us. 056. Za chwilkę to zaklei, tylko skończ, dobrze? No. There. So now we can import it. String. There. We need to specify it with or provide it with a type, and so essentially this is where you specify the type. So that's sorry, it's not a type, it's actually the length of the buffer that the string is going to have available for, you know, pushing and popping data. So this is, as an example, this is equivalent of, I guess, 4 bytes that you can give it, but in our case 4 bytes won't be enough, so we'll probably... Ciupuś, możesz się ukryć, nie pytaj się taty. Możesz się odkryć. So we're probably talking about some 16 bytes that we will need. And we need to specify those in here, in consts. Okay, this looks like this looks like a more Rust analyzer shenanigans, because it builds correctly. So anyway, so we have our string. So this is essentially equivalent to, you know, specifying array like this, something like that. I guess something like that. There. And we want this to be mutable, because here what we're going to do is, so we have our string, we will take down our counter, and blah blah blah, because we need it as mutable. So now we have this and we have this, and we need a formatter essentially. So we can use the we can use our, I think it's in the core. Right, there it is. This, then use the write macro, string, text, your placeholder for data, unwrap, and just write the text. It could even be to be more explicit. So I think we're good. We only need to well, make this a little bit lower. So, lower, which is this. The moment of truth. Didn't work because of this. So our only problem is the refresh. So the timer is running quicker than the refresh. And that's probably because of our tone playing stuff. So for the time being, let's just boom. Or let's just play it once. But right now it's fine. Just to see, and actually maybe so that's a little bit more noticeable. Let's fire the timer a little bit quicker. I don't know. 50 Hertz. There it is. So basically, this is the principle that you can apply to, I think, all the other stuff now. We're sharing the resources, we're sharing the data between this. We updated the variable here. We read it in here in a different, so we're sharing the data between the tasks. We have So we have the LCD where we send data over SPI. We have the timer peripheral. We have the PWM working. So like that's a proper embedded application that we have there currently. And I would say that the Arctic made it quite easy to build. And it's still counting. So yeah, I guess that's where we'll stop for now. Okay, the baby is sleeping, so I don't think... Yeah, the baby is sleeping, so I don't want to really wake her up. But maybe let's just have a quick look at the PWM output. So ground is this. The channel 0 is this. And it's A15. So yeah, no buzzer, but I guess we can... Fast. Boom. Oh, let's enable the song. Yeah, we just uncommented it in here. Let's rebuild it. Boom, that's our song. Now it's updating the display. Ah yeah, because we moved it outside of the loop. But yeah, that was our song. Yeah. So I guess we're done for today. So probably the next time, I don't know, we'll see if we can maybe add some buttons to the board and maybe interact with it a little bit, because there's no buttons on the board itself. But yeah, that's it for tonight. Bye bye.